Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. Now see the next chapter, Thermodynamics. From this, two questions come in NEET exam. So this chapter weightage is 8 marks. Many students feel difficult this chapter because different types of numericals and concepts are there. But you need not scare about this chapter. If you learn concepts perfectly and practice the numericals, definitely this chapter will become easy. So, see the first one. Thermodynamics. So, what is the meaning of this thermodynamics? The subject deals with quantitative relation between various forms of energy in physical and chemical processes is called thermodynamics. Say this, in quantitative relation between various forms of energy. Energy is available in different forms: heat energy, electrical energy, mechanical energy. In this way, in various forms we have energy. So what is the relation between these various forms of energy? These various forms of energies we can observe in physical and chemical processes. So this chapter gives the relation between different forms of energy in chemical processes and physical processes. This thermodynamics deals heat changes occurring between system and surroundings. Between the system and surroundings, how heat changes absorbed from system to surroundings, heat energy transferred, or from surrounding to system, heat energy transferred. How heat energy changes takes place, we can see in this chapter. Next, it helps us to predict whether a particular chemical reaction occurs on its own or not. So this thermodynamics gives the information about a particular chemical reaction takes place on its own or it does not take place. That information we can get from this thermodynamics. This thermodynamics has some limitations. See them. The laws of thermodynamics: 0, first, second, third law. That means 0th law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. So based upon the experimental facts, 4 laws were proposed. Those are called laws of thermodynamics. These laws do not give any idea about the rates of the processes. Rate of reaction means how the particular process takes place. That means what is the speed of the process, occurs very fastly or slowly or with moderate speed. That type of information is not given by these thermodynamics laws. Whether the particular process takes place or not, only that information we can get from this thermodynamics. It predicts the energy transformations and feasibility of a process. Here, feasibility means possibility. A particular process, whether it is physical or a chemical process, possible or not, and what are the energy transformations in that process. Those things we can get from this thermodynamics. Now, see the next one. Pressure, volume, work. It is also called mechanical work. For this, formula is W equal to minus P delta V. Here delta V means volume change, volume difference of final volume Vf minus initial volume Vi. Here W is positive when work is done on the system. W is negative, work is done by the system. Work is done on the system means in which case we can expect this positive work done: compression. If a gas undergo compression means work is done on the system, then positive work done. And expansion means work is done by the system. Here system is gas. Gas undergo expansion and compression. Compression means work is done on the system. So W is positive, work. Compression, expansion means work is done by the system. So W is negative. Remember, here work is a state function. Already we know that state function. What is that? The macroscopic property or the thermodynamic property which depends on initial and final states of the system irrespective of the path followed by the system to reach that final state is called state function. This work depends on initial and final states of the system. It does not depend on the path how that final state is reached. That is not affecting value of the work. So work is a state function. See the numericals. 2 liters of an ideal gas at a pressure of 10 atmospheres expands isothermally into a vacuum until its total volume is 10 liters. How much heat is absorbed and how much work is done in the expansion? So initial volume is given 2 liters, final volume 10 liters at a pressure of 10 atmosphere. Now how much heat is absorbed? The absorbed heat energy and the work done in this expansion we should calculate. Very simple question. Heat absorbed Q equal to minus W. Here W means minus PdV. So already here negative sign is there. So minus into minus plus. So external pressure PEX means external pressure into delta V means final volume minus initial volume. Final volume 10, initial volume 2, external pressure 0 because here expands into vacuum. Vacuum means external pressure 0. Remember that important point. 10 is not the external pressure. Okay, expands into vacuum. Vacuum means external pressure 0. So 0 into 8 that equal to 0. Therefore, no work is done and no heat energy is absorbed. See the next one. When an ideal gas of 4 liters expands isothermally at a constant external pressure of 1 atmosphere until its total volume is 10 liters, how much heat is absorbed in joules and how much work is done in the expansion? Here given a conversion 1 liter atmosphere equal to 101.325 joules. In terms of joules, we should calculate absorbed heat energy and work done also we should calculate in joules. Initial volume how much? 4 liters. Next final volume. How much final volume? 10 liters. So heat absorbed Q equal to minus W that equal to P external pressure into delta V. External pressure is 1 atmosphere into final volume 10, initial volume 4. Then we can get 6 liter atmosphere. This is absorbed heat energy. This value we should convert into joules. 1 liter atmosphere equal to 101.325 joules. Now 6 liter atmosphere means 607.9 joules. So heat absorbed Q equal to 607.9 joules. Work done in the expansion W equal to minus 607.9 joules. Already we learned in the previous topic. Expansion of the gas means work done by the gas. So work is negative. That's why here a negative sign is used. Okay students, we will meet in the next class.